Cutting tool materials. First one, carbon tool steels 10 to 15 meter per minute. Medium alloy steels, poor properties above 200 degrees Celsius and inexpensive. Uses taps and core drills for machining soft materials and woodworking tools. Second one, high speed steels HSS 35 meter per minute. Hot hardness is quite high, so the HSS cutting tools remain the cutting ability up to 600 degrees Celsius. Wear resistance is high and hardenability is good. Uses drills, milling cutters, taps, lathe cutting tool, gear hobs, etc. are made of HSS. Third one, carbides 70 to 120 meter per minute. A hard material made of compacted binary compounds of carbon and heavy metals used to make tools that cut metal. Made using powder metallurgy and usually used as an insert. Last one is ceramics 350 to 400 meter per minute. High abrasion and high hot hardness. Not good for interrupted cutting. Requires dry or constant profuse cutting fluids. Cutting tool materials. All carbides, when finished, are extremely brittle and weak in their resistance to its impact and shock loading. Due to this, vibrations are very harmful for carbide tools. The machine tools should be rigid, faster and more powerful. Light fits, low speeds and chatter are harmful. Due to the high cost of carbide tool materials and other factors, cemented carbides are used in the form of inserts or tips which are braced or clamped to a steel shank as shown in the following figure. Methods of attaching inserts to tool shanks. Types of cutting fluids. Cutting fluids are used in metal machining for a variety of reasons such as improving tool life, reducing workpiece thermal deformation, improving surface finish and flushing away chips from the cutting zone. Practically all cutting fluids presently in use fall into one of four categories: straight oils, soluble oils, semi-synthetic fluids, and synthetic fluids. Straight oils are non-emulsifiable and are used in machining operations in an undiluted form. They are composed of a base mineral or petroleum oil and often contain polar lubricants such as fats, vegetable oils and esters, as well as extreme pressure additives such as chlorine, sulfur and phosphorus. Straight oils provide the best lubrication and the poorest cooling characteristics among cutting fluids. Types of cutting fluids. After the previous video, which is straight oils, soluble oil fluids form an emulsion when mixed with water. The concentrate consists of a base mineral oil and emulsifiers to help produce a stable emulsion. They are used in a diluted form, usual concentration 3 to 10%, and provide good lubrication and heat transfer performance. They are widely used in industry and are the least expensive among all cutting fluids. Semi-synthetic fluids are essentially combination of synthetic and soluble oil fluids and have characteristics common to both types. The cost and heat transfer performance of semi-synthetic fluids lie between those of soluble oil fluids and synthetic fluid. Synthetic fluids contain no petroleum or mineral oil base and instead are formulated from alkaline, inorganic and organic compounds along with additives for corrosion inhibition. They are generally used in a diluted form, usual concentration 3 to 10%. Synthetic fluids often provide the best cooling performance among all cutting fluids. Properties of cutting fluid. A good type of cutting fluid should possess certain desired properties such as good cooling capacity and lubricating qualities, rust resistance and stability for long life, resistance to rancidity and foaming, non-toxic, transparent to allow the operator to see the work clearly during machining, relatively low viscosity to permit the chips and dirt to settle quickly, non-flammable to avoid burning easily and should be non-combustible, ability to dispose of in an environmentally responsible way. In addition, it should not smoke excessively, form gummy deposit which may cause machine slide to become sticky or clog the circulating system.